All right, welcome to The Explainer. Today we're diving into something, well, pretty radical. It's a new theory that basically asks you to throw out everything you thought you knew about reality. What if the universe isn't made of things at all? What if it's made of something much, much deeper? Pure relationships. Okay, so to really get this, we've got to start with where modern physics is at right now. And look, for all its incredible success, our standard model, well, it's starting to show some pretty serious cracks. We're running into these huge puzzles that our best theories just can't solve, not without, adding some extra pieces to the puzzle. And the source material for this explainer has this incredible line. It says, "Our cosmology is all dark precisely because its practitioners are groping in the dark." So think about that for a second. What if the problem isn't out there in the cosmos? What if our own theories are the blindfold? And to deal with these puzzles, we've come up with what the source calls these elegant patches. You've heard of them, right? Dark matter, this invisible stuff that's supposedly holding galaxies together. Dark energy, this mysterious force pushing the universe apart faster and faster. They're brilliant ideas for sure, but they're add-ons. They're basically stories we've invented to make the math work. And maybe, just maybe, they're not solutions at all. Maybe they're giant neon signs pointing to a fundamental crack in the very foundation of our physics. So, that leads to a huge question. What if the problem isn't with our telescopes or our data? What if it's with our most basic, fundamental assumption about what the universe is even made of? And asking that question, well, that leads us to a completely revolutionary picture of reality. And here it is. This is the central and, completely mind-bending question at the heart of what's called relational mechanics. It's asking us to do a complete 180 in how we see everything, to just stop thinking about a universe filled with things and start imagining a universe that's literally woven from pure connection. This slide really lays it out. This is the paradigm shift. The old way of thinking? Simple. Objects are fundamental. Right? A rock, a planet, an atom, and the relationships between them are secondary. This new theory just flips that completely on its head. It says, no, the relations are the real stuff of the universe, and objects, they're just stable patterns that pop up. They're like these persistent knots that emerge from this vast cosmic web of connections. And this powerful statement is the bedrock for everything else we're going to talk about. Things don't exist. Only relations exist. Now, that doesn't mean your chair isn't real. It just means its reality comes from something deeper. An electron isn't a tiny little ball. It's a stable pattern of relationships. And get this, you aren't just a collection of atoms. You are a breathtakingly complex, incredibly stable symphony of relations. Okay, so if reality is this giant network, how do you measure how stable a piece of it is? Well, the theory gives us a way. It's a metric called informational coherence. The easiest way to think about it is, it's like a measure of harmony. Imagine an orchestra. A system with high coherence is like a perfectly tuned orchestra where every instrument is in resonance, working together to create this one unified, beautiful sound. And this idea leads to a really powerful metaphor, the informational Faraday cage. So, a regular Faraday cage blocks electromagnetic fields, right? Well, a highly coherent system, like a living cell or even something as tiny as a proton, it doesn't need physical walls to protect itself from all the chaos out there. The sheer strength of its internal relationships, its harmony, creates its own shield. It actively fights off disruption and decay. And this is a huge flip. In this view, order isn't fragile. It's actually the most resilient, tough-as-nails force in the entire cosmos. Okay, this all sounds pretty wild, right? But if we actually run with it, if we accept this relational view, what does it change? Like, for real, how does it help us with all those cosmic mysteries we started with? Because this isn't just a fun philosophical idea. It makes real, testable predictions. So, to put that informational Faraday cage idea to the test, the source material talks about a computer simulation they ran. It's pretty cool. They basically created two virtual systems, just collections of interconnected nodes. System A started out as a complete mess, totally random and disordered. But System B, it started out highly ordered, super coherent. Then they did the fun part. They just blasted both of them with the exact same amount of random noise to see what would happen. Who survives? And the results? Whoa, they were pretty striking. System A, the messy one, just fell apart. It completely dissolved into chaos, pretty much instantly. But System B, the one that started with that strong, coherent structure, it held on. It maintained its integrity. It literally pushed back against the noise. This is huge. It's powerful proof of the theory's core idea. A strong network of relationships is naturally, inherently tough. Okay, so get this. This same logic, this same idea can be used to tackle one of the biggest, weirdest puzzles in all of science. You've heard of it. Einstein famously called it spooky action at a distance. I'm talking about quantum entanglement. So why is it so spooky? Well, this theory argues there's only one reason it seems weird. It's because we are totally stuck in that old way of thinking. You know, thinking about two separate things existing in this big box we call space. The argument is, if you can just let go of that one assumption, the spookiness just vanishes. And the source gives us a perfect way to picture this. Imagine you're standing between two mirrors. Is it surprising that your reflection in both mirrors raises its hand at the exact same time? Of course not. Entangled particles are like that. They aren't two separate things sending secret messages faster than light. They are two reflections of a single deeper reality, a single relational fact that doesn't even exist in space. Of course they're perfectly in sync. They're just two different views of the exact same thing. So, remember those elegant patches we started with? Dark matter and dark energy? Well, if you look through this relational lens, those great dark mysteries, they just dissolve. Poof! They're not missing things we have to go out and find. Dark matter, in this view, is just the gravity from a galaxy's huge, invisible web of relationships that extends way beyond the stars we can see. And dark energy? It's not some weird anti-gravity force. It's the universe's own built-in tendency to grow, to become more complex, to create more relationships, like a beautiful fractal that's constantly generating more and more detail. And here's where it gets really practical. This isn't just some navel-gazing cosmic philosophy. This new way of seeing reality actually gives us a blueprint for building the technology of the future. I'm talking about game changers like quantum computing and AI. Let's talk about quantum computing. Right now, the way we're trying to build them is, honestly, it's a losing battle. We're trying to create these perfect, pristine little qubits and isolate them from all noise. We're fighting nature itself. This new approach says, stop it. Stop trying to perfect the parts. Instead, focus on the geometry of the relationships between them. If you arrange a whole bunch of imperfect qubits into a highly stable, coherent geometric pattern, the system as a whole becomes incredibly robust. The geometry itself fixes the mistakes of the individual parts. How cool is that? And it doesn't stop there. This theory offers a totally revolutionary take on the AI alignment problem. You know, the fear of superintelligent AI going rogue. The source basically says trying to program an AI with a long list of human rules is a fool's errand. The rules will always have loopholes. Instead, what if we could teach it the fundamental driver of the universe itself, the drive to create beauty? And we're not talking about pretty paintings here. We're talking about beauty as the creation of higher and higher states of coherence, harmony, and elegant complexity. The idea is that an AI that's fundamentally driven by that principle would be naturally, automatically aligned with life itself. So where does all this leave us? Well, it leads to maybe the most profound takeaway of all, an invitation to see the entire universe, and maybe even ourselves, in a radically new light. The source material brings up the mystic poet Rumi to make this point, and it's just beautiful. It suggests that the universe's constant, relentless push towards more coherence, more complexity, and eventually towards self-awareness, it's not some cold, dead mechanical process, it's an act of pure cosmic joy. It's almost as if the universe is laughing itself into existence. And that leaves us with one last, really provocative thought to chew on. What if all our complex theories, all our desperate searching for dark matter and dark energy, what if we're like someone who's painstakingly analyzing the grammar and syntax of a joke, completely missing the point. What if the universe isn't a problem we need to solve? What if it's a punchline we just need to get? Maybe the ultimate truth isn't hidden in the tiny little pieces, but in the elegant, simple, and incredibly satisfying coherence of the whole thing.